Okay, so now we're going to go over how to find general angles of trig functions. And these are angles of trig functions that just show up so commonly that it's good to just go ahead and have these memorized here. So your guys' job is to tell me, what does sine of pi over 6 equal? Okay, now to start off with, we're going to draw a coordinate plane up here. Okay, and we're dealing with our angle of rotation. Now, some of us maybe can look at pi over 6 and know what that angle of rotation is actually going to be, and some of us will not. So the first step that we would want to do for most of us is we're going to want to convert that pi over 6 into degrees. So remember, our conversion factor for this is 180 degrees over pi, because those two equal each other. Okay, and my pi's would end up canceling. I end up with 180 degrees over 6, which when I divide 180 degrees by 6, I get 30 degrees. So remember our triangles that I said in that last video that were important, 30 degrees. So what we're going to have here is we are now going to have a 30, 60, 90 triangle, because this triangle is 30 degrees right there. Our theta is 30 degrees. Okay, so I draw my angle of rotation, and I've got a 30-degree angle there. Now, we can fill in. What goes across from the 30 degrees? Well, that's the smallest angle, so my smallest length. That will be a 1. Okay, here we have drawn it to make a 90-degree angle, so that means my largest side, my hypotenuse, will be there. And then the last one I have is my square root of 3. So the first part is we converted it into degrees. Then we drew our angle of rotation. Okay, we figured out, hey, special triangle, I saw 30 degrees. So this is a 30, 60, 90 triangle. And now I drew my special right triangle up there, and I filled it in. Okay, now the question that they asked me for was sine of pi over 6. Well, that's the same thing as what is sine of 30 degrees. Well, what is that? Well, sine equals opposite over hypotenuse. So if I come back up here to my triangle, opposite would be 1, it's across from the 30. My hypotenuse would be 2. Okay, so sine is opposite over hypotenuse. So that means I would have 1 over 2. So the sine of pi over 6 equals 1/2. Okay, and that's it. You're going to draw your coordinate plane up there like that. Okay, once you figure out what special triangle you are doing, you're going to fill in that special triangle, and then you just answer sine. Okay, and we remember our SOH, CA, TOA. Okay, so opposite over hypotenuse, it asks for sine, and I just fill in my numbers, and that's my answer. I have 2 more that I want us to practice over here. Okay, you've got tangent of 60 degrees, so that one we don't need to worry about converting. And then you have cosine of pi over 4. That one you will want to convert. Go ahead and pause the video. Remember, draw your coordinate plane first because we're doing an angle of rotation. But pause the video and try and do these 2 on your own. Okay, hopefully you guys have paused the video and tried to do them. Okay, tangent of 60 degrees. Okay, so this is 60 degrees here. Again, 60 degrees, that's setting up our 30, 60, 90 triangle. Okay, so across from my 60, remember 60 is my middle one. This one up here would be my 30-degree one, so this is 1. Square root of 3 is the one that's across from 60, and 2 is up here. Okay, so tangent of 60 degrees equals, so sorry, this is bad C, TOA. Okay, so tangent is opposite over adjacent. Opposite over adjacent. If I come down here to my triangle, my opposite across from the 60 would be 3. My hypotenuse would be 2, which leaves adjacent to be 1. So opposite is my square root of 3. My adjacent is 1, which square root of 3 over 1 would just be square root of 3. Okay, so the tangent of 60 degrees equals square root of 3. And that's it. That's all you have to do. Okay? Cosine of pi over 4. Cosine of pi over 4. Okay? Again, if you haven't paused the video, pause it and try and do this one on your own. Draw my coordinate plane. Okay, I need to convert pi over 4 times, what would that be, 180 degrees over pi. Okay, well, your pi's would cancel. You're left with 180 divided by 4, which gives me 45 degrees. So we've got 45 degrees here. Okay, now that is not a 30, 60, 90 triangle. That is still a special one, though. This would be your 45, 45, 90 triangle. So for the 45, 45, 90 triangle, you'd have 1s in both of these spots here. And your hypotenuse is a square root of 2. Okay, so the cosine of pi over 4, okay, we want cosine. I'm wanting cosine here. So that is my adjacent over my hypotenuse. Okay, so the adjacent side, this here would be opposite. Hypotenuse, that means 1 is my adjacent, would be 1 over my hypotenuse is square root of 2. So 1 over square root of 2. Now, we do have one added step with this because remember from back in additional lesson 5, I believe it was, back in January, you cannot have square roots on the bottom of fractions. So to get rid of that square root, I'm going to have to multiply by a square root of 2 on the bottom, and I do the same thing on the top. Now, when I do that, 1 times the square root of 2 just gives me square root of 2, and then square root of 2 times square root of 2 gives me a square root of 4. Because remember, if they're on the inside, we can multiply them together. Okay, so that ends up giving me a square root of 2 over 2. Okay, so the cosine of pi over 4 equals square root of 2 over 2. Okay, and you could also write that the cosine of 45 equals square root of 2 over 2. Okay, and that's how you guys find the general angle for these trig functions. Now, the next video, we're going to do the exact same thing, but we're going to take it one step a little bit further, and we're going to see some negatives show up in there. Ooh.